In this video, I'll talk about estimation and prediction using multiple linear regression. So we're using our delivery truck example again. So just to recap, we have two predictors, miles traveled and number of deliveries, and our response variable is travel time. And we fit our model and got these estimates for the slope, for the intercept, and then the parameters multiplying each of the predictors in turn. And then we can use our estimates in an equation to predict y for any combination of x1 and x2. So minus 0.869 plus 0.06113 times 100 plus 0.923 times 4 comes to 8.9385. That's our predicted y for x1 equal 100 and x2 equal 4. So we're interested in an estimate or a prediction for when x1 is 100 and x2 is 2. And we're going to think about two different types of estimation or prediction. The first one is what we're going to call an estimation. And this is an estimate of the mean travel time for all trucks that travel 100 miles and make 2 deliveries. Okay, so let's think about that. So our estimate for the mean travel time is calculated the way I just mentioned, minus 0.869 plus 0.06113 times 100 plus 0.923 times 2. So that comes to 7.09. That's our point estimate, but we would like to put an interval around that number to represent the amount of uncertainty we have in our answer. And so to do that, we're going to use a standard error. So the standard error here is called SY hat, and it's the standard error of estimation. And it's fairly complicated trying to calculate that number from scratch. So we're going to obtain that number from software, particularly Excel stat. So that's where this number is going to come from. But then once we've got this number, then we can calculate a margin of error and use that margin of error to come up with an interval. So that's what this does here. So it uses a percentile from a t-distribution, and for a 95% confidence interval, if we put 0.05 in here in this t.inf.2t formula, then that will calculate the correct percentile for us. And then C21, this is the degrees of freedom for that t-distribution. There's 7 degrees of freedom here. It's always given the degrees of freedom for anything based on the t-statistic or the t-distribution. It's always given by the error degrees of freedom for the model. So that's our margin of error, that t percentile times the standard error of estimation, and then we subtract that from y hat to get our lower bound, and then we add it to y hat to get the upper bound. So these two numbers give us the confidence interval for the mean, so we can say that we're 95% confident that the mean travel time for all trucks that travel 100 miles and make 2 deliveries is in our interval. Okay, so that's estimation. What about prediction? So now, rather than thinking about all trucks that travel 100 miles and make 2 deliveries and thinking about the mean travel time, the average travel time for all those trucks, we're going to pick an individual truck, one specific truck that travels 100 miles and makes 2 deliveries. And we're going to try and predict the actual travel time for that truck. So that's a much harder problem. Okay. much harder than trying to estimate the average for a whole bunch of trucks. Trying to predict the actual travel time for that specific truck is much more difficult. So to reflect that additional difficulty with that prediction compared with the estimation, we're going to have an interval that's much wider. And to get a wider interval means the standard error is larger. So this standard error of prediction, you can see 0.6729, it is larger than the standard error of estimation, 0.3526. And again, it's kind of complicated calculating this number, so we're just going to get it from software. 0.6729, this number we'll obtain from software. But then we can calculate the interval using the usual method. Calculate a t percentile, or critical value, if you like, and then multiply by the standard error of prediction. That'll give us our margin of error, and then subtract it from y hat, our point estimate, and that's our lower bound, and our upper bound, we simply add the margin of error to y hat. So these two numbers tell us we're 95% confident that the actual travel time for this specific truck that travels 100 miles and makes 2 deliveries is in this interval, 5.5 up to 8.683. And notice how it's wider than the interval was when we were trying to estimate the mean travel time for trucks like this. So let's see how to get these intervals using Excel stat. So fit the model as usual. And then under prediction, if I click that box, and then it will prompt me for our explanatory variables. So our explanatory variables are here. And then now if I OK it, it will fit the model as usual, but there will be an extra piece of output that will have these confidence interval and prediction intervals. So let's just make the output a little bigger so we can see it. Okay, and then scroll down, 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 down. Okay, here it is, predictions for the new observations. X1 equal 100, X2 equal 2. Here's our point estimate, 7.092. Here's the standard error of estimation, and here's the confidence interval for the mean, 6.258 up to 7.925. So that's these numbers here. And then here's the standard error of prediction, and here's the prediction interval, 5.500 up to 8.683. That's these numbers here. Okay, so that's estimation and prediction for the multiple linear regression model.